Hello geometry students, this is 7-4, proving triangles similar. Your learning targets today are students will show that the altitude to the hypotenuse divides right triangles into two similar triangles. And we'll talk about what an altitude is and kind of go over as a review what a hypotenuse is. Students will use the right triangle altitude theorem to prove relationships between the sides of the triangle and the altitude. Your vocabulary today is hypotenuse, and in Spanish that's hipotenusa. Hypotenusa. Legs, catetos, right triangle, triángulo, rectángulo. And geometric mean, media geométrica. So we are going to pause the video in a bit to do this activity. Suppose you cut a rectangular sheet of paper to create 3 right triangles. That's what we're going to do. You will use appropriate tools. How can you compare the leg lengths and angle measures among the triangles? Are any of the triangles similar to each other? Explain. So you're going to get a piece of paper and a ruler and scissors. For this next problem, it's called Pythagoras' plank. And they're asking us to find the length of the plank, or a long stick, in this right-angled triangle that just touches a 3-meter square in the corner, as the diagram shows. Right, so we want to know this length here. And I want us to have some discussion about it. Like, what are you noticing, and how might we figure this out? To conclude our notes for today, we're going to talk about an inscribed right triangle similarity theorem. We have a theorem that says the altitude to the hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original triangle and to each other. So we're saying here that we have triangle CAB is similar to triangle DAC and is similar to triangle DCB. So all 3 of those. And we saw that in our exploration when we were cutting out the rectangle and we had the 2 triangles and we measured their angles by lining them up, and we saw that their angles were similar. And because yesterday we talked about angle-angle similarity, we know that if at least 2 angles are similar, then the triangles are similar. So let's look at this problem. We're going to apply this theorem. We have triangle PQR. And we're saying it is similar to QSR. We want to know what is Q to S. To see this a little bit better, I want to break this triangle apart. So we have PQR. I'm just going to draw this PQR. This is the blue one. So P to Q is 20. And you can see that right angle is at Q. So this is Q, this is P, this is the right angle. And then we have me just think about that. Yeah, the hypotenuse, we don't have the measure for because it's pieced together. So we just have the 20. That's this blue one, PQR. Then we have the green triangle, which is already sitting on its right angle. QRS. So it's just easier to see that they are similar when we break them apart. Just like with our paper, how we cut them apart, made it easier to see. Now I'll just label those as 9 and 15. Using what we learned yesterday about proportions, we can set up a proportion here to compare sides. So we have the side, what sides do we have that correspond? We do have this side, I'm sorry, we have 15, because Q to R is 15. Now it'll be easier to correspond sides. And what we're trying to figure out is QS. So we want to know this, QS. That's what we're looking for. So let's set up a proportion. And we can say that P to Q is 20, and Q to S is what we are looking for. And then we also can say that 15, which is Q to R, 15 in the big triangle, corresponds to SR, which is 9 on the smaller triangle. So these, if we set them up as a proportion, because we know that they're similar, we can do that. We want to cross multiply and then divide. So 20 times 9, that's 180. And 180 divided by 15 is 12. So that means that QS equals 12. So we can solve these similarity triangle problems by setting up a proportion.